Okay, so I will share my screen now. Is my screen visible? The voice audible, everything's fine, right?
Yeah, sure.
Yes, is
Okay. So today we are just going to discuss about the NumPy. I hope you have already heard of at least this library. Okay, so in MLT you had learned about so many mathematical terms, right? Like to calculate the covariance matrix. So if you'll start from the first week itself, where for the PCA you are about to calculate the covariance matrix and then calculate the eigenvector, eigenvalues, all those things, right? And then in the many of the algorithm also you have a lot of mathematics, right? So what happens here? Why basically this library came out? So this library in the starting, so it's like see many of the you have many of the languages, but mostly for ML generally we use the Python because when Python was developed, it was very like just because of the user friendly, so it was very easy to understand, right? So other languages, even though it was easy, but it was not that as compared to the Python, right? But the problem with Python was it was a bit slow as compared to the other languages. Okay. So to make it faster, there are there are many libraries that was made. Okay, because in the starting, what happens? So whoever developed Python, right? So and the whole the people thought of to go with Python for ML, right? Because it was very easy to understand it. Okay, but as in the ML, we have to deal with a lot of data set, right? Millions of data set, right? To develop any algorithm and all. So just to use the Python data structure, those are already available, like the tuple list and all. It was very difficult to use those data structures. Okay. So that's why they came up with the idea that to develop libraries. Okay. So this libraries basically has been developed with some basic languages like the C and all, like the NumPy. It has been developed with the help of language C, right? And then we are putting it in Python to just to make it faster. Okay, because with list and tuple, it was very difficult to deal with big data set, right? So that's why the many libraries has been made, like pandas, NumPy, and then later the PyTorch and all has been developed just to make it faster. The Python is fast, and we'll see that also when a simple addition or multiplication, element-wise multiplication that you will be doing with the help of the list or a tuple, and then you will do with the help of the NumPy, right? So there will be a big time difference that it will take just for a simple mathematics, like a simple addition. It will take a lot of time for if you are just doing with the help of the list. Even when you were doing the addition, let's for example, you have to do addition with the help of the list, right? You it will not directly do the addition, right? You have to take out one element from each of the lists and then add it and then again make it as a list, right? But the NumPy, basically the name itself is like numerical Python, right? It was just made to make our like mathematics easier. So there are so many modules, many of the modules are there, like the whole linear algebra modules are there. So whatever you were doing, say the rank calculation or maybe the eigenvector, eigenvalue. So you have already a module in the NumPy itself. So this library consists of whole of mathematical module, okay, and a different and a lot of you have functions, right? In this module, so you have a linear algebra module, and in that module itself, you have a lot of functions, right? So that will make our life easier. So we'll start with so in ML also, when you were dealing with, you were just starting with some sort of a vector or maybe a sample space, right? Let's, for example, here it has been given, right? X, right? That consists of 1, 2, 3 as a value, right? I hope you are able to see that. So this consists of some three features, right? That features can be height, weight, or width of some product, something like that. Okay, and that is represented in the form of some sample space, right? This X, and like in you call it as a vector also many a times, right? So now what you have to do is this vector we have to tell the, so somehow you have to tell our computer also, so this is a vector, right? And how do we generally going to represent that? So in the Python you can do it with the help of the list also, there's no problem in that. But the problem that I told you, right, the time complexity. So if you just do it with the list, because here it's fine, you have just have a three features, right? But in normal data set that you will be dealing with, you can have an n number of like and can be very large, right? And you will be dealing with a large sort of a data set. Data set will be a large, and then we'll be having each data set will be having a large number of features itself. Okay, so then it becomes very difficult to represent that with the help of the list. So will be how we are going to tell our computer that this is a vector or whatever we are, if we are dealing with a big matrix consist of n cross d or whatever d cross n, whichever you want to represent with. So we'll be taking the help of the NumPy. Okay, so for the NumPy, we first have to import the library, because I told you, right, it's a library that has been made with some different languages, and then we have kept it in the Python. Okay, so first of all, we'll just be importing that library, that NumPy. So it's pretty simple to import a NumPy, like import NumPy, and then you can give some nickname to this NumPy. So we are giving it as a NP. Okay, so whenever we have to call this NumPy, we'll directly write it with, in spite of writing NumPy, we'll just be writing NP itself. Okay, is that clear to everyone till now? So this is just a basic introduction about the NumPy, how it came and all those things. Okay. So now from here we'll start. So I hope you have already opened this the collab, like whatever I've said, the Google Drive I've shared with you. In that you can just open this copy of a vector and then make up another copy. Okay. So that will be, you can just directly start from there. So you have to just import this. First of all, you can just write it as import NumPy as, and you can just give a nickname to them. So as MP. Now, I told you, right, you can, so let's, for example, X, Y is some sort of a vector or some sort of a sample space you have, and then you have to do the addition. I'll tell you how, if you are just telling like computer with the help of the list, okay, so you can do that addition. There's no problem in that, okay. How can you do that? Can somebody tell me how will you do that if you are using two lists? You can take list comprehension also, or maybe you can do that element wise also. How will you do that?
Using for loop and then index value.
No, a list can be directly be added x plus y, I think.
Okay,
Sir,
so
one
first
doubt.
let's define it. Yeah.
Sir, one doubt.
L of I plus J of I.
Yeah. What's the doubt?
Hello.
Yeah. Go ahead. Yeah. Go ahead. I can't hear you. I can't hear you. Like. Okay. Okay, leave. You can just write it in the chat box. I hope I'm not able to hear you. Yeah. Okay. So okay, let's do it. So if let's, for example, these are the two lists.
So we can also write using while function.
Okay, then like you can just denote it. Okay, you can create one empty set or empty list, and then is it audible, right? Yeah.
Yes, audible.
Yes, sir.
Yes, sir, you are audible.
Yeah, so in that you have to take it element wise, right? So let's, for example, from X, you just take the first element, ith element, you add it to white ith element. And then you can just take it I from where to where. So you have how many elements? 3 elements, right? So you can take the I in the range of length of any of the vectors. Any of the vectors, you can take it A or B, anything. That will give you. Right. So this is one method, or maybe you can do it with the list comprehension also. You can use the method, I hope. Zip also you can use. There is no problem. So XY has already been defined. Okay. One more thing, whenever, see in the Google Colab, right? Let's, for example, I have defined XY. These are the simple list. So you have already learned about the list, and then we have added we have taken. So in the list, you can't directly write X plus Z, right? X plus Y. You can't write it as, you have to take out one of the element from one of the list, and then like the other element from the other list, and then you can keep on adding, and then you can have in the end you have a list itself, Z as a, so it was like element wise addition has been added, right? Now you can do it with the help of the other method also. Now what I have to do is I have to, like, why we are trying to use the numpy, so that we have to check first. Okay, so I told you in the starting there's a, like, the first thing is the time constant. Okay, so let's, for example, now how will you, so this vector that has been given to you, with the help of the numpy, how will you tell your computer that this is a vector, one of the vector? Okay, or you can just think of as a column vector or row vector, whatever you want to write, like think of. As of now, we'll come later, we'll see that how generally you define this. If you have been given a vector or if you have been given a matrices, how will you define with the help of the numpy? So as of now, let's, for example, this x. So the first thing that we have done with the help of the list, right? Now with the help of the numpy, so we have defined numpy as np, right? So np dot, and numpy takes, so it was in the form of a list, right? So we are just converting a list into an array. So numpy will do everything in the form of an array, n-dimensional array. Okay, so if you are dealing with a one vector, right, and that vector, so it will deal with one-dimensional array. If it was a matrices, then it would have dealt with a two-dimensional array. Or if it was, let's, for example, a three-dimensional, okay, cascaded matrices, then it would have dealt with three-dimensional array. So as of now, I'll just brief you what I have said it from starting. So you can do in like the whole mathematical term, you can do it with the help of the list also. With the help of the list, you can add it like this. But now, why do we use the numpy? So with the help of the numpy, you have been given some vector, right? X, Y, Z, whatever has been given to you. That list, you will convert it in the form of an array. So numpy does everything in the form of an array, okay? N-dimensional array, okay? So in vector, if you are dealing with just a vector, so this is a vector, right? 1, 2, 3, it has some one sample space in the form of a vector. So that generally is a one-dimensional array, okay? If you are dealing with a matrices, okay, where you have something, you are going from top to bottom and left to right also, right? How do you write a matrix? It's some form of a table, right? In that table, something right from top to bottom and then from left to right also. So that consists of some column and some rows, right? So there, if you have to write that matrix, okay, at n cross d or d cross n matrices, right, then you will use a two-dimensional array. So as of now, we are just dealing with a vector that will be defined in the form of one-dimensional array. Okay, I hope this is making sense to you guys. Is it clear to you?
Yes.
Anyone? Okay, so now,
Yes, sir.
how will you define a vector? So yeah, so X was what? A vector that consists of 1, 2, 3, three features, right? So with the help of the numpy array, this is how generally you will tell your computer that this is a one of the vector, okay? 1, 2, 3 that consists of element 1, 2, and 3, right? So X has been defined. Now you can define Y also. NP the same method array, and then you'll give a list, whatever the 4, 5, 6, right? And then you'll see that when now if you have to add it, right? So you can directly add it like X, directly the simple math that you do, right? You just write it as X plus Y and then it will do. Because this, and then see, if you have to get the output, you can directly write it as it is. The final, the last line in the Google Colab that will give you the final, the answer, okay? And if you don't want it, just give it a semicolon, it will not be giving you the answer, okay? So you can just write it. If you need Z as output, you can directly write it in the last line whenever you have to run it, okay? So 5, 7, 9. So you got same from both, like list, from the list also, if you're using the list method. And let's, for example, if you're using the normal, the numpy method, then also you got the same value. The difference will come when you will check how much time generally it takes to do this, the both addition, okay? We'll do it, but not now, we'll do it in the end, okay? Because I have to go and then define the other things also. We can do that, the time, how to check the time also. For the time, we'll have to again import another library that is time basically, and then check the timing. We'll do it in the end, okay? As of now, the only one thing I have told you that if you have been given a vector, you just tell your computer with the help of the numpy that this vector is a one-dimensional array. So in the numpy, you'll just be in the form, because you are dealing with in the n-dimensional array. So vector is generally a one-dimensional array. Okay. Now, so here also the same thing. So we have done already done. If you have a vector, let's for example 1, 2, 3, how will you define with the help of the numpy? So np dot, whatever the array that has, like you just write it as np.array, and whatever the list that has been given to you 1, 2, 3. So directly you are converting that list to in the form of a NumPy array, and that the array is of one dimensional itself. That is going from top to bottom. Right? Is this clear to everyone?
Yes, sir.
Is it clear to everyone? Okay. Yeah. So addition part we have done it. So if you have to just add it, so you can directly write it here. So you have just defined and vector 1, 2, 3 with the help of the NumPy array, and then you have defined y also with the help of the same, and then you have added, right? And then you got the answer, right? Now what you have to do is, so now you can see that, so we can directly write it. So when you were defining x and y with the help of the NumPy, right? So you can directly do this mathematical operation, right? Normally the way you do, right? Directly you can write it as positive. So it becomes very simple, right? So in the list you have to take out one of the elements from one of the list and then the other from the other list, and then you keep on adding, and then again the output should be in the form of a list, right? Here there is no problem. Like you just give it in the form of an array, the x and y, and then the output that you are getting, that is also in the form of an array itself. So you are adding two vectors, and then in the end you are also getting in the end also you are getting an array that is one dimensional array. That means it's a vector itself. Okay. Now what you have to do is you have to do like, let's for example, the second thing that we are doing is element wise multiplication. So you have been given x and y. So again the same thing, you can just define it similarly. So x and y has been defined with the same value 1, 2, 3, and now what you have to do is you have to take the Hadamard product. Okay, so element wise product you have to do. Okay, so the element wise product, let's for example, if you have to do the product that you use, right, star, you can directly use it as it is, and then the final output you can directly get it as. It's pretty simple, right? The way that you do the normal mathematics, like you write it in normal mathematics, right? With the help of the NumPy, you can just do it as it is, right? So there's no like thing that you have to think of. So it becomes very simple for you, like. So now the next thing is, now you have to do is scaling, right? Let's for example, the vector that you have defined. So x is a vector that you have to define, np.array. Just give the list 1, 2, 3, right? And then what you have to do is scaling this vector that you have. So you have now this vector has been defined in the form of an array. Now what you have to do is scaling, right? So 3 star x, right? See what generally it does, and there is a beautiful concept of broadcasting also. So what happens in the NumPy? See, we have just given 3, right? But this 3 got multiplied what in each of the element of this vector x, correct? So in the normal also, whenever you have whenever you do the scaling of a vector, what happens? Let's for example, you are multiplying some constant 3. So each of the terms generally would get multiplied with that constant, right? Here also, you have defined this x in the form of the vector that you were having, that you have defined in the form of an array, right? Now you are multiplying some constant 3, right? So what internally it does is, in the broadcasting, what it does is, broadcasting basically is a concept where this 3, right, whatever the scaling that you have done, this will get converted into a sum of 3 cross 1 sort of a vector. Okay, one vector, or you can say this 3, internally it will get converted into a vector that the value will be 3, 3, 3 itself. Okay, and then it will get multiplied. It will get multiplied with the 1, 2, 3 vector, like element wise. Are you able to understand this or not?
Yes.
No, sir. Can you please repeat it?
Okay, so what happens here is, see, in the starting, we have started with additions and then the multiplication, right? So here in the multiplication, so you were given 2 vectors, right? And 2 vectors you have to multiply element wise, right? 1 should get multiplied with 4, and then 2 with 5, and 3 with 6, right? So what you have done, the normal mathematical term that you write, right? X star y. So this is how generally you do the multiplication, and this vector got multiplied. So this, whatever the value it was there, this 1, 2, 3 got multiplied with 4, 5, 6 element wise, right? Now the next thing is you have to scale that vector. So if you have been given a vector 1, 2, 3, so with the help of the NumPy array, you have just defined this in the form of a x that consists of 1, 2, 3. Okay. Now what you have to do is scale that vector. So if you have to scale this vector 3 cross x, right? In the normal vector, what happens? You just multiply this 3 to each of the elements, correct? This is what you do. So here also, so internally NumPy, what it will do is, it will convert this 3, the scaled value 3, into a 3 cross 1 sort of a vector, okay, where the values of that vector will be 3, 3, 3 itself. And then element wise, it will multiply with 1, 2, 3. And then it will give you the output as 3, 6, 9. Okay. So broadcasting, will learn it later also when you'll be dealing with the matrix. Maybe there you'll get more idea about that. So as of now, this itself is clear, right? So this, if you have to scale some vector, you can directly write it as it is, as generally you write it in the form of a mathematics. Okay. Making sense?
Yes, sir. Yes, sir.
Okay. Now, yeah. So now the next thing is, what you have to do is element-wise function of a vector. So now you have been given some function a vector has been given to you. Let's, for example, scaling a vector x by a constant k can be seen. So now let's, for example, you were having a vector x1, x2, so whatever the till xd. Now you are multiplying some constant k. So that we have learned, right? You can directly multiply it as k star x, right? And you will get the final vector, the scaled version of that vector. Now, the next problem is, let's, for example, you have to define x squared. So whatever the value, let's, for example, 1, 2, 3, 4 was a vector. 1, 2, 3, 4 is a vector. How will you define with the help of a matrix numpy? Can somebody tell me how will you write it as?
NP dot array.
So M by array and the same thing.
NP dot array, and then
Bracket
correct.
within square bracket.
1,
1,
2,
3, 4.
1,
Correct.
2, 3,
Okay. Now I have to get the square of all this value. How can I get the square of this value? In the normal mathematics, what you would have done? X square, right?
Yes, there are two possibilities.
Correct.
Yes, star yes.
This is what you do, right? So here also, yeah. So here also you'll do the same thing. X squared, that's it, and you'll get the 1496. It's pretty simple. If with the help of the numpy, if you have defined your vector with the help of the numpy array, right, then it becomes very simple. The normal way that you do the mathematics and all, you can just write it in the same way. Here also x square, that's it, and then you got the output as the x squared matrix. X squared, not matrix, a vector. Correct? Is clear? X squared you have to do, right? You can just, with the help of a simple array, so like numpy array, you have defined that vector, right? 1, 2, 3, 4, and then you have the square of that. Now, let's, for example, you have to take the log of that value. What will you do? Again, you will define it. So you just define it. So you can't define, okay. Let's, for example, you have defined it, a vector 1, 2, 3, 4, right? So here, let's take some big value. So here the given value is what? 1, 1, 0, 100, 1000, 10,000, and then 1 lakh. Correct? So a vector has been defined x. Now you have to take the log of this whole thing. How will you take? So there is a, in the numpy, okay, you have this function log itself. See, and then okay, you can take the base. If you have, take base as 10 and then apply this x itself, and then you will get it like this. See, you have defined this, the matrix, whatever has been given, 1, 10, 100, 10, whatever the matrix has been, whatever the vector that has been given to you, right? And now what you have to do is apply a logarithm function, right? If you have to apply a logarithm function, so this numpy itself has a function log itself. You can just check it. Like, let's, for example, you have to get an idea about this np.log 10. You can have log 2 also. So let's check it. So to get any idea about any of the functions, right, of numpy, you can directly write it as question mark and then plus shift plus enter, whatever, and then you will be getting an help, like, so you can get an idea about this np.log 10. So you can just see that what will it return. So it will return a like n-dimensional array itself. So your vector was in a 1-dimensional array, so it will return a 1-dimensional array itself, and then the value will be in the form of a log 10. So it will directly calculate that, right? So log of 1 and then log of 10, 100 and in itself, and then it will give you in the form of a float value. Okay, so you can just see that, and again you can get an idea. So here you have been given an example, right? And then you can see all the things, right? So any function, if you have to get an idea about that function, you can directly write it as question mark, and then you can just get help from Google Colab itself. Okay, clear?
Yes.
Okay. Now the second thing is, now you have to use ln, like the same thing, log base, right? Yeah. Whoever has raised, Vivek, can you just let me know what's the doubt?
Sir, what is the difference between the log and ln?
So
Log
that
and
is like
ln.
you have already passed maths, right? So log is, so you can just write ln as log of e itself. Like whenever you are
Okay.
writing ln, that means
Log
yeah, the
is to
base is
e,
e.
right?
Yeah,
Okay.
yeah. Okay. So now you can just, how will you define this? Again, you can just define it as np dot array, and then you can give it in the form of a 1. See, np has some constant also. So numpy has some constant also. So you can just write it as np.e. So that will give you the like epsilon, that whatever you write it as. Okay. Now again the same. The other thing is what, e square, right? So again you can give it as np dot e square. The next thing is np dot. So you got all the values. So yeah. So this is this is the vector that you have defined in the form of an array. Now what you need is you have to apply ln, right? So the same thing you can do, right? So numpy has dot log of x. Then you got the answer. So see, you can just check it also. Here also again you can check it. Like what happens, what are the base that are available in the numpy, right? So you can just get an idea from here. So you can read it. This all. See, you can see that log of 10, log of 2, log 1p, all these things are available in NumPy. Okay, if you just want to get the final output, if you want to apply log of base 10, then you can directly use it as log 10 that we have used earlier. If you want to take the log of base 2 also, that is also available. Okay, so these are all things you can get an idea. So if you are just writing log, that means what? It will take the base as e. Okay, can somebody tell me where have you used this log ka concept in MLT?
Maximum likelihood calculation.
Okay. Any other place?
The entropy calculation.
Entropy. Okay. In the log, logistic also you would have used, right? Logistic regression. Yeah. Aryan, you have any doubt? Are you guys doing along with me?
Sir, why did you wrote
okay.
NP.e? Why don't you write
Yes, we are doing
only
along with
Okay. Yeah. So now the next thing is you have a function, right? X
sir,
plus
in the
c.
previous
So,
question, sir,
yeah.
excuse me, sir. In the previous question, why you wrote np.e and then whole thing? Like
Yeah, because
to get
NP has some constant. Let's
absolute
for
value?
example, yeah, let's for example, if you need, so MP has some constant value also. So NumPy has, let's for example, pi also. I guess this is how it gets. Let's check it whether, yeah. So NumPy has the pi also as like this.
Okay.
NumPy p
I got it.
also.
Like to get the absolute value, we can do this, no?
Correct. Yeah. So that also NumPy has. Okay. So the some of the constant also that has. Okay, you can just
like we
get
don't
an idea.
write e and e square directly, no?
Yeah, correct.
Thank you so much.
Okay. Now the next thing is, let's for example, you defined a vector 1, 2, 3, right? So let's for example, the same thing you are defining. I'll just so np dot array, and then you define it 1, 2. Yeah. Go ahead.
How to find all the constants which is already defined in NumPy?
So what you can do is the documentation.
The
See, after that,
the help
yeah,
file.
help also you can, or what you can do is you can go through the NumPy documentation, right? That is available. So this, whatever we are doing, that those are very essential. Whatever you just have to do it for this 3-4 days, right? So those only constant and everything we are dealing, that is going to help you in the tomorrow, whatever the like PCA and the regression that you'll be doing. So those are the only things we are dealing. There are a lot of things else that you can go through the documentation of the NumPy. So there you can get more idea about so all the different types of function or the module that are available in NumPy. Okay. So we are just mostly will be just be dealing with the how to define the vector matrices with the help of the array, and then we'll go to the linear algebra part. So mostly we'll be dealing with the linear algebra module itself. So these are some basic things that we are dealing with that will give you an idea to just write the code for the 3-4 algorithms that we are going to deal with. Okay. Okay. So now let's, for example, x plus c you have to do. How will you do that? You can just write it x plus and some constant is 5, right? It will just, again, which concept will be used here again? Can I define like as some broadcasting? Correct. So again, it will use the same concept of broadcasting. Correct. So what we'll do is you have already a vector 1, 2, 3, right? Now what we'll do is 5 is just a constant, right? So what internally it will do is it will just create a matrix. It will create a vector of 3 cross 1, some column vector it will create. The value will be 5, 5, 5. Okay, and then it will add element wise. Okay, and this is what will happen here. So 1 got added to 5, and then again 2 got added to 5, and 3 got added to 5, and then in the end you will get 6, 7, 8 as answer. Okay. Okay, how will you define this? Like, how will you write this? Can somebody tell me? It's pretty simple, right? So you just write it as -1, then 0, escape, and then
Excuse me.
yeah.
In previous, there's the question is in question there is power t is in the transpose.
Yeah. That, see, one more thing.
5 into x minus.
See, vector, if you are dealing with a vector, right? So whenever you are dealing with a vector, so when you have used the concept of the array, right? With the help of the array, you have defined the vector, right? And that vector that you are getting, right? The vector that you have defined with the help of the array, that basically is one-dimensional array. Okay, so you take transpose or not, right? Both are same only here. Okay, you are not dealing with a matrix, right? A column matrix. Okay, let's, for example, this vector, if you would have represented with the help of a matrix, right? So there, the transpose and everything will get changed, right? So the column matrix will get converted to the row matrix. But here we are just dealing with a vector. Okay, so in the vector, when we are dealing with this, and you are using a one-dimensional array, you take a transpose or not. Okay, both are same. Okay, this has been represented. Why it has been written 1, 2, 3 transpose? Because it will be in the form of a column vector. Okay, that's why there is nothing else. Okay, is it making sense?
Okay.
Yeah. So here also, you have been given -1. So one vector consists of 4 features has been defined with the help of the one-dimensional array. Okay, and then 5 directly you can write it as
Brackets here? Shouldn't there be square brackets?
Yeah. Correct. There will be. You can take a tuple also, but it's fine. 5x minus 2. And again, here also, it will use the concept of broadcasting internally. Okay, and then if you want to get the y, the output, it will give you the output as it is. 5 times. So again, the 5 will get 4, like a 4 cross 1 vector. Okay, and then -2. So this also internally will do the broadcasting, the concept of broadcasting, and then it will give you the output as it is. Okay, the way normally you do it in the mathematics. Now the next thing is the dot product. Okay, I hope dot product you have used it a lot of places, right, to calculate where have you used in the PC also you have used, right, to get the projection, right? The dot product you have used a number of times. Now, if you have to use the concept, so again here also you can define x and y. So I'll just copy it from there. So the same thing is getting repeated. So I hope at least as of now, you got an idea of how to represent at least a vector, right? Now, NP. So you give a list -4, -5, -6, -7. Okay. Now, if you have to get a dot product, so the NumPy has a function dot itself. So NP dot. And then if you'll give it x, y, it will directly calculate you the dot product. Okay. There are other methods also. So the dot product, you got it as -60. Okay. If you want to represent in the form, so you can just give it as give me the integer value of this, right? It will give you the integer value, right? So there is other method also. The very basic method to calculate the dot product is like x and y you have defined, right? At the rate. You can just write it as at the rate and it will give you the final value as minus 60. Okay? Is it clear?
So why it's showing int 64 minus 60? Because
Yeah,
it's
this is in the form of an int. Yeah. So if you want to get minus 60, right? You just write it that integer value of this. So it will give you the minus 60 itself. Okay?
Okay.
Yeah. So and the very basic, so at the rate also you can directly use it. Either you use np dot product. Okay. So the numpy has a dot as a function also, or you can directly use it as x at the rate y. That will also give you a dot product. Okay. We'll see the the use of that at the rate also when you will be dealing with the matrices. Okay. So now let's, for example, if I'll do it y at the rate x, what do you think? What will be the value that I'll be getting? Whether it will be same or different?
Same.
Same, sir.
It will be same, right? Yeah, it will be same. See, that's the beauty of this number. So here, too, if you have a two vector, you'll take the dot product. Always you'll be getting the same value. But later you'll come to know that, see, whenever, if, let's, for example, you have a matrix and then you have to multiply a vector also, so it will accordingly adjust. So if, let's, for example, you have some 4x4 matrix and then x is some 4x1, or let's, for example, you're just represented in the form of a vector. If you want to get ax, right? So always you use at the rate, okay? And if one is matrix and one is vector, it will automatically convert that accordingly. If it wants 1x4 as a vector, it will directly convert it as 1x4. If it wants 4x1, it will directly convert it as 4x1 and it will give you the output. Okay, we'll deal with that in the coming time. But as of now, I just give you an idea that if you use at the rate, right? If you can use it dot also, there's no problem. Or mostly you can use it as at the rate. Okay, it will give at the rate you can use if there is some matrix multiplication, matrix multiplication, or matrix vector or vector matrix multiplication, or even the this three condition, you can directly use it as at the rate. Now the next part is, if, let's, for example, you need a vector of all zeros or all ones. Okay, so there are a function itself in the numpy. Let's, for example, you need zeros, a vector of zeros itself. So zeros. Yeah, np dot zeros. And then let's, for example, you need how many values you need in this tuple? You need 5 values, right? So you can directly write it as 5.
ROS, sir. ROS.
Okay, I guess E doesn't, yeah. Okay, and then let's, for example, you want to represent this. Correct? So you are getting a array, right? Having 5 values, okay, as 0, 0, 0, 0. Cell. Let's, for example, you need a ones, right? So again, in numpy has a function ones also, and if you want to represent this, yeah. So here also you are getting a vector that has 5 element, right? 1, 1, 1, 1, 1. Okay. So these are some of the basic functions. So that will come to know that how you are going to use this zeros, ones, and all. Okay. Now, what if we want to create a vector? All of those elements are equal to 5. How can you get a vector? All of the elements.
5 into np
No,
dot
5.
By scaling it.
Correct. Yeah, you can use the scaling. Correct. So np dot ones, you should be having 5 elements and then multiply with what? 5 itself. Correct. And then if we'll just represent it, we'll be having a vector that consists of 5. Like all the element will be 5 itself. Clear?
Or you can use np dot full.
Yeah, that also you can use it. Correct. Now, let's, for example, there is I guess in the Python, in the list, you would have used the range itself, right? You generally use a range, right? To get, let's, for example, the sequence of data, the sequence of mathematical number if you need, right? You are using ranges. So here you have arrange, I guess, np dot, let's, for example, and let's, for example, you need 5 element, right? So 1 to 6. So 6 will not be included. And then, yeah. So you got an array that consists of 5 element, 1 to 5. Okay.
second element is excluding.
Yeah, the final element, if you are getting from 1 to 6, the last element in the list, when you were using the range also in the list, right? The same thing was happening, right? In the Python also normal, if you use the range from 1 to 6, it will give you the element from 1 to like 1, 2, 3, 4, 5 itself, not the 6. Okay, the last element generally excluded. Okay, now let's say example the norm. So you'll be dealing with, when you'll be dealing with the regression model, the ridge and the lasso that you'll be dealing. Okay, so there also you'll be taking help of this L2 and L1 norm, right? I hope you have studied the L2 and L1 norm, right? Now, if you have to calculate the L2 norm, how will you calculate the L2 norm? So first you have to define this vector 1, 2, 3, right? So np dot array 1, 2, 3. Now, what do you have to calculate? So in this, if you have to calculate the norm, right? L2 norm you have to calculate.
So
So in
one
this
question,
Numpy, you have a
I
module
can
linear
interrupt.
algebra. Yeah. Go ahead.
So the NumPy by default takes only 5 elements in its array, or we are not specifying anywhere how many elements should the array contain, but still it's taking only 5 elements. So is it by default or something?
Where?
For
Here,
example,
right?
in
In
the
once we have,
in once it is
we are giving
giving
5
5
elements, right?
elements. Okay.
Because we are giving 5,
What
right?
about 1,
If you
2,
would
3,
have
4,
given
5
6,
in that? Okay. Okay, sir.
if you would have
Got it.
given 6, you would have given 6, right? If you would have given 7, you would have
Okay.
given 6, right? Element from 1 to 6. 7 is excluded. Okay.
Okay. Thank you.
Yeah. Now we have to calculate the L2 norms. Okay. How will you calculate? So this NumPy has a linear algebra as a module also. So linear algebra, you can see that, right? Linear algebra as a module. And in that linear algebra, you have something called norm also. Okay. Norm of X you have to calculate. So by default, it will calculate, I guess by default, it will calculate L2 norm. So you can just check it also. Yeah, so this will give you the norm, right? And then there is a, I guess, order, right? So you can just change the order also if you want L2 norm or L1 norm, right? So by default, it is giving you L2 norm, I hope, right? It can give you L2, L1 norm also. So for that, I guess you have to change. Let's say example here. Where is that? Okay, let's try it out. So let's, for example, X you have to calculate and give it order as, I guess, order only. You give it as 2. So it will calculate you the L2 norm. Yeah. And then similarly, you can calculate L1 norm also, right? Similarly, you can calculate L1 norm also. So the last element will get, so 6 is the L1 norm. Yeah. So somebody was asking any doubt? What's that? Okay.
What the order is?
Order L2 norm, L1 norm, you have read, right?
Yes. Okay.
Yeah. So that is what. So if you have to calculate the first order, the L1 norm, so generally that calculates it takes the mod and then summits all the values, element of your vector, right? L2 norm will be the Euclidean distance that you calculate, correct? So this is how generally you calculate.
Thank you.
Yeah.
Sir,
Now,
linear algebra comes under NP and norm comes under linear algebra, right?
Yeah, so correct. So linear algebra has an attribute or a function of calculating the norm. So see, you can just think of as there are something called attribute and something called function, right? So any object that you're dealing with, right? Any object, let's for example, that's a beautiful example. Like let's for example, you have a car, right? Attribute are like some specification of those car, right? That car can be blue, black, whatever color, right? But let's for example, it has to do some function. So you'll write it in the form of like parenthesis, right? So if it is written in the form of a parenthesis, that is what, if you want to calculate if you want to do some function on that. So if you want to, on X, if I want to do some function, whatever the function that I'm writing, so if, like, for example, Numpy has some function, right? So to calculate the summation. So if you will write it to do a summation, you'll write it in the form of a parenthesis. Okay. If you want to get an idea, like what is the shape of this X or what is the size of this X. Okay. So there you'll use some of the things that generally you call it as an attribute. I hope that is making sense. Okay. So here, let's for example, the shape and dimension I have to get for a vector, right? So here, whatever I'll be using, that will be the attribute. Okay, not the function. Okay, but if I have to, let's for example, I have to do like summation or mean, like mean, I have to calculate for this. Okay, that is a function that I have to apply on that, right? So there we'll be using some parentheses. Okay. Okay, so now I have to get the shape of this dimension. So first I have to define this np.array 1, 2, 3, 4. Okay, that is defined. Now, I told you this was a vector that consists of 4 elements, 1, 2, 3, 4, right? Can somebody tell me what will be the shape of this vector?
4 comma that only 4 comma
4 cross 1.
No, not 4 cross 1. If it is 4 cross 1, then you have not understood what I have said in the starting. I said, yeah. Okay. 4 comma, that's it. So because this is in the form of some tuple, right? So whenever you calculate, you check the size of a tuple, shape of a tuple, right? That generally gives you the number of elements, that's it. So here, whenever you are defining a vector with the help of a NumPy array, one-dimensional array, right? So because you are dealing with vector, right? So the vector, to define a vector, you were using one-dimensional array. Whenever you are dealing with a one-dimensional array, so there the shape will always be, it will just be giving you the number of elements, that's it. Because whenever you're writing a vector, right, you're just writing it from top to down or left to right. You're not using both, right, top to bottom and left to right. To write it a tabular value or a matrix, you will use it from left to right and up to down, right? Are you getting me or not? So here, whenever you have to define a vector, you are using one-dimensional array, correct? If you're using a one-dimensional array, so I have defined X, and let's for example, I have to check the shape, right? What should I get? 4 comma dash. So number of element, that's it. What do you think? What will be the dimension of this vector? What will be the dimension? 1, 2, what?
1D.
And here, why I'm not using parentheses, the bracket? Because we are dealing with we just want some characteristic of this X. We don't want to do any function on that, right? If you should have used some function, you would have used that parenthesis or the bracket, right? But this is the attribute, right, of X. So we just want to know some characteristic of this. So if you check shape, right? So that is 4 comma, that's it. 4 comma is the number of element it will give you. So this is in the form of some form of a tuple. So the vector that you were having, so you to tell the computer, right, this is a vector, right? You used one-dimensional array. In that one-dimensional array, whenever you will check the shape, it will just be giving you the number of element. That number of element can be infinite also. Okay, from 1 to infinite. So it would have given you the infinite comma, that's it. But the shape would have been the same. Let's for example, I have defined 5, 6, 7, 8. What do you think? What will be the shape? Shape will be 8, 0. That's fine. What will be the dimension of this vector?
One dimension.
Dimension will always be 1, right? You take it any number of values, it will always be 1. Correct? So I hope this you have understood. Okay. Now let's deal with the matrix. Okay. Then we'll go to the Matplotlib. So let's finish it off the NumPy and then we'll go to the Matplotlib. Okay. So I'll just open the other file. So now the first collab is done. Now you can open the third collab, the matrices collab. Okay. So you are doing right with me or you're not?
Yes, sir.
Yes, sir.
Okay, now you can open the third collab, the matrices. Okay, make a copy of that and then is my screen visible now?
Yes. Yes.
Okay. Now again, you just import connect it and then import the NumPy as nickname as NP Generally, you call it as allies, but okay, that's fine. Now, so now you have a matrix that consists of three vector, like not three vector, three element x1, x2, x3, having three features each. Okay. Now, can somebody tell me how many dimension you'll be using? How many dimension of array you'll be using to define this matrix? I told you in the starting how many you will be using.
3 dimension.
3 dimension.
3 dimension or 2 dimension?
3.
No, 2 dimension you'll be using here.
2 dimension.
See, to define an array, so to define this matrix with the help of array, right? You'll just be using 2 dimension. Why? See, dimension that you are dealing here, right? In the form of an array to tell the computer, okay, this is a matrix, okay? How generally you are able to tell with the help of 2 dimensions. So vector, whenever you are having a vector, that can be a big number, any number, okay? So you are just using 1 dimensional. So you are starting from top and going to bottom. So you're just using 1 dimension. Here to write a matrix, you are going from top to bottom and left to right. So 2 dimension only, right? Correct? So do not get confused with what you are writing in the MLT, right? 3 cross 3 for this matrix. That is different thing. As of now, to define this matrix with the help of the array, you will just be using 2-dimensional array. Are you getting me or not?
Yes.
Okay.
Got it.
Yeah.
Yes, sir.
Okay. Okay. So now I have to define this M, right? So let's define this M. How will I define? NP dot array. What should I write here? See, I'll just give you an idea. Whenever you write it,
another pair of
correct. So first is R1. R1 is generally the first row. Okay, then give a column. This you can just not remember, but understand it. This is R2 and this is R3. This is how generally you define a matrix with the help of 2-dimensional array. So whatever the number of nected like the big bracket that you have, right? That many dimension that matrix, that many dimension that array has. Okay, let's for example here. Yeah, how did you define this? This R1 is the first row, then the second row, then the third row. Are you getting me? This is how generally you define a matrix. Tell the computer with the help of the matrices. Okay. Are you able to understand this? How many of you are able to? Okay. Yes. So now,
yes, sir.
R1 is what? R1 is 1, 2, 3. Correct? And then you have 4, 5, 6. Correct? And then you have 7, 8, 9. What do you think? So this, we have defined a matrix. M, let's for example, just represent this. 1, 2, 3. I told you this is the first row. 1, 2, 3. Second row is 4, 5, 6. Third row is 7, 8, 9. Let's, for example, I'm just to make it more clear. Let's define a vector here. NP dot array, one vector having value 1, 2, 3. Now, just tell me what will be the shape of M? What will be the shape of M? Shape I'm asking. What will be the shape?
3 cross 3, 3,
3 cross. Correct. 3 cross 3. Shape is the normal, like the thing that you are doing in the mathematics, right? N cross N matrix that you are dealing with. So here, if you just have to check the shape, that will be 3 cross 3. But if you have to check the shape of X, X is a vector, right? It is the form of some tuple, right? So if you will check the shape, here you'll just be getting, what is this?
You didn't run that cell.
Okay. Now
Sir,
you'll be
it's
getting
M.
3 cross. That's it. The number of element. That's it. Correct. But here you got for M you got 3 cross 3. Now the next thing is
why not 3, 1 here?
Where? No. So this is not a matrix. This is not a matrix of 3, 1. This is just a vector. That is what from the starting I was telling. To define a vector, you can define a vector in the form of a matrix also. When, let's for example, I have to define this 1, 2, 3, this vector in the form of a matrix. How will you define? Can somebody tell me how will you define this?
Yes. So np dot array and
then
one pair of parentheses inside that one another pair of parentheses
Double bracket
and 1.
Correct. Yeah. So this is what? This is a row vector or a column matrix, sorry. The vector that was there, 1, 2, 3. Now if I'll run it, right, this X is what? A row vector or a column vector? What do you think?
Column.
It's a row vector, right?
Row vector.
I told you, right? This is R1. So this is a row vector, correct?
1, 3 will be shape.
Correct. Now, this vector 1, 2, 3, I want to write it in the form of a matrix. So let's here, I'll just write it as Y and then here Y, so that in the end, whenever, okay. Now, let's for example, I want to write this vector 1, 2, 3 in the form of a matrix. Matrix and that too column vector. How will you write the column in the form of a column matrix? How will you write? Can somebody tell me?
Each number inside a square bracket. Like
correct.
Square bracket,
correct. So,
open, close one.
The first one should be what? 1, then comma 2, comma 3. Now, this will be what? This will be a column vector. Just take. See, this is column, right? I told you, right? This is R1, R2, R3. Okay? Any confusion anybody has?
No, sir.
No, right. Now, you have to tell me what will be this. Okay, first of all, what will be this shape of X? What will be the shape of X?
3, comma.
Correct. The number of elements, that's it. Correct? What will be the dimension of X? What will be the dimension of X?
1.
The dimension will be 1. Correct.
Sir,
sorry, there will be 1. Yeah, it will be 1. Yeah, it will be 1. Now, what will be the shape of Y?
3, comma 1.
One.
No, 1, comma
3. 1, comma 3.
1, comma
This will be 1, comma 3. Correct. Because this vector you are representing with the help of matrix. Correct. Now, what will be the dimension of this Y? What will be the dimension of Y?
2.
Correct. The dimension will be 2 because you have taken the help of matrix. You have represented with the help of 2-dimensional array. I hope now is clear to everyone, right? What is the difference between if you are directly represented a vector with the help of 1-dimensional array or if you have represented in the form of a matrix? Clear to everyone? Clear, right?
Yes, sir.
Yes, sir.
Okay, let's move to that. So, yeah, now I hope everything is clear to everyone. Now, if I have to add...
What is the dimension of M there?
What do you think? What will be the dimension of M?
2.
It will be 2 or 3. Correct, 2. Dimension will be 2. Shape will be 3 cross 3.
3 cross 3.
Okay? Yeah. So the dimension is 2y. How many arrays you are taking help to tell the computer that this is a matrix? 2-dimensional only, right? Left to right and top to bottom. That's it. Correct?
So, sir, a matrix of any order will have 2 dimensions, correct?
Correct. Yeah. Any matrix will have a 2-dimensional array. It can be infinite cross infinite, but you'll just be using 2-dimensional array. Okay. If a vector is there, it can be from 0 to infinite. The value that can be as large as possible, but you'll just be using 1-dimensional array to represent it. Okay. Clear?
Yes, sir.
Yes, sir. Yes.
Okay. Now, if you have to do the addition, right? How will you do the addition? Okay, let's finish this itself and then we'll do the matplotlib. How will you do this addition? Is pretty simple, right?
Just
how will you define A?
Symbol.
Correct. Same.
Sorry, within double bracket.
What?
Within double, we have to use 2 square bracket.
Correct. Yeah, right? Similarly, you can just define B itself. I'll just write B also as same. Just to save the time. A. And then you can directly write it as A plus B. You'll get the output. Correct? So directly it has added. The way we were adding the vector, so here also it just added it. Now, scaling. Scaling, let's define A and then you scale it. Let's, for example, you have to scale it as 3 times of A. It will again use the concept of what? Broadcasting. It will make a matrix 3 cross 3 and then multiply, will do the multiplication element by multiplication with A. Okay. Is it clear to everyone?
Yes, it's clear.
Scalar
sir.
matrix of
Yes, sir.
Yeah, it will
right.
internally the NumPy what will do is it will just multiply element wise this three that we have given, right? It will just broadcast it and then make the matrix of 2 cross 2. So because A we have given as 2 cross 2, right?
Yeah.
The shape of this matrix is 2 cross 2. So it will create a matrix of 2 cross 2 with all the element as 3 and then multiply with A. Element wise multiplication, and then it will give you the output. Okay, that is what the element wise multiplication is here. Now, what you need
Here,
is,
what do you mean by broadcasting?
so broadcasting is a term, like a concept that the NumPy uses. Okay, so we'll deal with that, but as of now, I'm just telling you what generally it does. It does when, so automatically, so here it was 3 multiplication with A. So it directly converted the like 3 into or 2 cross 2 matrix with all the element as 3. If I would have added right here, then again it would have done the same thing. It would have made a matrix of 2 cross 2 with all the element as 3 and added to A. Okay.
Okay, thank you.
Yeah, and it will help you when you will deal. I'll tell you when generally it helps us. So here too, it is helping us. Broadcasting is helping a lot, right? To directly, so that we can becomes very user friendly, right? You can directly write it as, you don't have to write a matrix whole sort of all the values 3 3 3 3, right? If you're doing element wise, right? You can directly write it as 3. If you have to scale it, just multiply it. In the normal, what you do, if you have a matrix, if you just scale it, you just multiply with each of the elements. So here it is doing the same thing.
So it is just the formation of a 2 cross 2 matrix with all elements 3 is termed as broadcasting in NumPy. Is it? That's what is.
Yeah, it depends. If let's for example, if it was a 3 cross 3 matrix, then it would have made a 3 cross 3 matrix and
3
then added
cross
to
3
it.
with all
Correct.
Based on what is A or what is the matrix.
Correct. It adjusts itself. Yeah, correct.
Thank you.
So that's why that's why we use like NumPy, because that has been made in such a way that the mathematics that you do for ML, right, it becomes very simple if you use a NumPy. That's why we don't use list or what are the other data structure that are present in MATLAB. Now, if you have to do the same, like what method we have used to do the element-wise multiplication?
Just
Star you can use, right? Correct. So I'm not writing it. You can just write it. So you can just define A with the help of matrix, 2-dimensional array, B also 2-dimensional array, and then A star B. Correct? You'll get the value. Now, if you have to apply a function, what will you do? So let's, for example, directly take this matrix and I apply a function. How will I apply a function? Fx I have to apply and then apply absolute value. So there's in the NumPy you have an absolute function itself. Let's check ABS. Correct? Yeah, it's there. So you can directly write it as, and it will calculate the absolute. So it was already, so let's say example, this is minus. So now it will calculate the absolute value, 1, 2, 3, 4. Clear? These all things, so whatever, so there can be n number of functions in NumPy. Whatever we are dealing, those are the only thing that will be like important for whatever we are going to do the upcoming 2-3 days, the algorithm. That's why we are just sticking with the absolute or whatever the function that we have used, scaling and the linear algebra, rank calculation and all that we will be dealing with. Only those things that we are going to use it. Okay, there can be n number of functions in NumPy. Yeah, somebody is just raising their hand. Who is that? Okay. No problem. So let's deal with the next thing. The next thing is you have to take the square of that, right? That also you can do, right? So do I have to write it? No, right? See, how will you write this square root of 2? So that also, I guess, NumPy has sqrt, square root of that. Let's define it this at least. NP dot. Okay. What should I write?
2D array. So
1, 2. Sorry, not 2. NP dot
sqrt.
Okay, I don't want to use sqrt. What should I do then? 2 multiplication with what? 0.5, right?
Double star.
Double star.
Double star.
Correct. Yeah, sorry. Yeah, double star. Correct? Similarly, you can, the second row is what?
3
NP.
double star 1.
Yeah. Right. So here I can use it this thing, right? And then comma 2.
2.
Yeah, this value, right? And if I want to square it, the same. I can square. I'll put it. There. Now transpose. Okay. So one more thing. In the starting that I was dealing with the vector and all. Okay. So this was one vector, right? This is a vector. X is a vector. If I will take a transpose of this X, what will happen? Okay. Let's first of all I should tell you how to calculate the transpose, right? Then I'll go there. So a matrix has been defined. A matrix. Let's define a matrix M np dot array. And this is 1, 2, 3. The other part is 4, 5, 6. Correct? This is the matrix, right? Yeah. Now I have to take a transpose, right? So and NumPy has a transpose as a function also. Transpose. Let's see if there. Yeah, it's there, right? So NP has a transpose also, and you can calculate the transpose. Now, what will be the shape? What do you think? What will be the shape of this matrix? The transpose wala matrix. 3 cross 2. What will be the dimension? What will be the dimension of this matrix M transpose?
2.
2 only. That will always be 2. Yeah. See, I defined this. There can be other method also. Let's, for example, you can directly calculate M dot transpose also. Sorry, this is a function, right? We are applying to
M dot T, I think.
Correct. Yeah, there can be, yeah, correct. Yeah, M dot T also you can use. So there is very nice thing. M dot T also you can use it, right? If you use, yeah. See, there are so many methods, right? So this is the best method, right? You can directly use that M dot T. So that will calculate the transpose. The way you were writing, right? In the mathematics, you write it as upscript, right? So superscript transpose, right? So here you can directly write it as M dot T. So you'll get the transpose. Now, I told you, right? Dimension will be same, right? I hope there's no confusion in that. Now, now you know how to calculate the transpose. Let's come to this matrix, this vector. So that I have defined in the starting. What do you think? This vector that I have dealt with X, this vector that was a one-dimensional array. What do you think? What will be the transpose of this?
The same vector, I guess.
Matrix.
What will be the shape of this X transpose Y?
3 cross 1.
3 comma
1 cross 3.
Cross 3.
No,
3 comma 1.
that will be 3 comma only, because I told you, right? You are dealing with a vector. If we are dealing with a vector, that is one-dimensional array. If it's a one-dimensional array, you do anything. You do transpose or not do transpose. The number of element will be same, right?
Sir, but vector is always vertical or.
What vector is always?
Vertical.
No, see, when here what we are doing, a vector that you are having, right? That vector with the help of one-dimensional array that you are telling, with the help of the NumPy one-dimensional array, you are telling the computer, right? This is a vector. One-dimensional array, when you write, correct, that the shape will always be the number of elements, that's it. Because that is in the form of some tuple. So that will give you some number of elements, that's it, nothing else. But if you are representing that vector in the form of a matrix, 1 cross 3 or 3 cross 1, in a column matrix or a column row matrix, okay, then the shape will change. If you will take the transpose of that. Here it will not change. Because here the shape, generally for a vector, it just gives you the number of elements, that's it. Okay. See here, Y is there, right? Now, let's, for example, if you will take Y transpose, okay. Okay. Now, what do you think? What will be the shape of this A?
3 cross 1.
That will be 3 cross 1. Because earlier it was a row vector, 1 cross 3. Now you have changed it. You took the transpose, right? When you took the transpose down, the shape is changed. But the dimension will always be same, 2 dimensions, right? Is it clear to everyone or not?
Sir, so
Clear?
you're saying while uh,
See, while I just want to say, when you have been given a vector, if you are using one-dimensional array, okay, you take transpose or not take transpose, because you have just taken one-dimensional array, that will always be in the form of some tuple. You can just think of as column vector, row vector, whatever you want to. Okay, this is in the form of some tuple. Some array is there. That's it. That is written from top to bottom or left to right. Whatever you want to think of. Okay, that can be column or row vector. When you are just taking the help of one-dimensional array. But if you are taking the help of two-dimensional array to represent that vector, then it changes, right? Then the column vector and the row vector will be transpose of each other. Are you getting me? Or
Yes.
not? Yeah.
yes.
Now, what is the next thing? So the shape and dimension I already dealt, right? So there is no point of dealing it again. So this all things I have dealt to just remove your confusion. Vector, if you how to represent a vector as a matrices, right? I told you, right, how to represent a vector as a matrices in the starting itself. So this all things we have already dealt. Now come up here. If you have to multiply a matrix and a matrix as a vector, vector and a matrix, and a vector and a vector. Okay, this is a nice concept. Let's define A. A is np dot array. Okay, so 1, 2, 3. Okay, so you need one more bracket, right? Now that is 4, 5, 6. Correct? A is defined. What is the shape of A? What is the dimension of A? Can somebody tell me what will be the dimension and shape of A?
Dimension will be 2 and shape will be 2.
Cross 3.
Correct. Correct. So that will be 6, 7. Correct? Then you'll be having 8, 9. What is that? 8. What is the value? 8 only, right? 8, 9. You can click escape. Okay. And then you have 10, 11. Can you just please mute yourself? Ganya. So we have defined it. Correct? Yes, correct. Now you have to multiply, take the product. What we have used in the starting? Can somebody tell me? For the dot product, what we have used? At the rate.
Rate star.
Correct. No, star was for the element-wise multiplication, right? Correct. So you can use it
At
here
the
for
rate
add.
we use.
Correct. At the rate B. Yeah. So it will directly do the matrix multiplication. And then it will give you. So it was 2 cross 3 and this was 3 cross 2. So you'll get a 2 cross 2 matrix in the end if you'll do the matrix multiplication. Correct? Okay. Now, the best part is when you have to do a product of a matrix and a column vector. So let's define A first. If you just define A, np dot array is 1 cross 2 cross 3. Okay, one more bracket you need. Four, 5, 6, and then again you have a 7, 8, 9. Okay. So this has been defined. A has been defined. This B is a column vector. You can just see you are multiplying a vector to a matrix to a vector. What will be the output? Normally, if you're multiplying a matrix to a vector, what will be the output? A vector or a matrix?
Vector.
Vector.
You will get a vector, correct? Okay. Now, X, let's for example, I am defining NP dot array with the help of one-dimensional array 6, 7, 8. Now, I'll use the same thing at the rate. What it will do is internally, see, A is what, so here it is nice, right? We have to just calculate AX. So here there won't be any problem. You can directly calculate AX. So at the rate X, so it will directly calculate it and it will give you the final output. You can see that the final output that you are getting is a vector itself, correct? One dimensional vector you are getting, right? 44, 107 and 170. Are you able to understand this? So a matrix was given. You have defined a matrix with the help of two-dimensional array, a vector with a one-dimensional array, and the output you got it as it is, a vector. See, you could have taken, you could have defined this vector with the help of a matrix also. The answer you will be getting at the same, but the final answer you would have got in the form of a matrix. Are you getting me, right? So here, if you have to just multiply a matrix to a vector, you can directly use this at the rate. You just define this vector with the help of one-dimensional array, and you will get the final output as a form of a vector itself.
So
Yeah, go ahead.
if you do X at A,
if you do X at A,
yeah,
that is, yeah. So if you do X at A, you'll get X transpose A, because it can't, see here, the next problem, it is the same product of a vector and a matrix. Okay, so the earlier what we have done, matrix and a vector, you got a vector as output. Now what you are doing, vector times matrix. Okay, the same thing we will do.
so the broadcasting rules will transform it automatically, or we have to do it manually?
No, see, let's see. Here you can directly write it as X transpose A. Directly write it as it is.
Okay.
Here what will it do? See, that's why I was telling you, do not write a vector in the form of a matrix. If you would have written in the form of a matrix, you have to take transpose and then multiply.
Yeah.
If you're just taking the vector as it is, as a one-dimensional array, automatically it will convert it, whatever it requires.
So the broadcasting will like handle it automatically.
Yeah. So here, X transpose, it has calculated that itself and then multiplied with A. So you have given a vector 6, 7, 8, right? It directly, let's for example, you are just thinking it as a column vector. It'll try, if you have to calculate X transpose A, right? It'll directly calculate as 6, 7, 8 as a row vector and then multiply with that. Are you getting me?
Yes, sir, I got it.
Yes,
Okay.
sir.
Now, okay. Now the next part is, if you have to get X transpose Y, where X and Y both are vector. This is what inner dot product. So there can be n number of inner dot product. Inner product, dot product is one of the inner products, right? How can you calculate the inner dot product? The same thing, right? You can just define X and Y. You just write it as X transpose Y. It will directly convert, right? It will directly convert one of the two as a transpose and then multiply it, because at the end you will get the value will be same. You do X transpose or Y or Y Y transpose X. Okay, you'll get the same thing. The dot product you're doing, right? Are you getting me? In the starting, I told you, right? If you do, you are having two vectors. In the starting, we dealt, right? I guess one of the first collab we dealt, right?
Yes.
Are you able to remember that, right?
Yes.
The dot product that we have calculated. Here also, you can define X as a 1 with the help of one-dimensional array, Y also with the help of one-dimensional array, and then calculate X at the rate Y, we'll get the dot product. Because we have started at the rate where we have used the first, the at the rate. The dot for the dot product, you can take NP dot also for the X and Y, but you can take the help of X at the rate Y. So that at the rate that you are using, right? This is helping you a lot, right? When you have to multiply matrix, it was using matrix, vector matrix, all the places you were able to use it, correct? And the best part was it was converting automatically vector in the form of a column vector or a row vector. So you don't have to think what we are giving. As a column vector we have to give or a row vector we have to give. But if you would have used two-dimensional array, then you have to think what you have to calculate. And then you have to give it as it is, like with the help of transpose or whatever. you have to take care of that. If you are multiplying, then the number of that should be equal, right? So if you are multiplying 3 cross 3, then the first part of the second matrix should be 3 itself. Otherwise, it will not multiply, right? Here, if you are giving in the form of a vector, you don't have to worry. It will adjust itself. Okay. Is it clear? Making sense to everyone or not?
Yeah, making sense.
Yeah, Karthikeyan or Abhijit, whoever has a doubt, you can just let me know.
So this X cross A and A cross X. This I'm not clear. The previous one, yeah.
Yeah.
Because
So
the
you have to
answers are
calculate.
different. It is multiplying differently.
What? A cross?
X cross the previous one. Yeah. This one.
Yeah. A cross S. What you are trying to do? You are trying to multiply a matrix with a vector, right?
The product of the below one, the one which is below. This
so
one.
Here what you are trying to do is multiply a vector with a pre-multiplication of a vector. Correct?
Yeah.
So what do you think? If you would have taken this X as a column vector, where you were able to multiply XA, what do you think? If you would have taken a column vector 3 cross 1, can 3 cross 1 can be multiplied with 3 cross 3? No, right?
Yeah.
So
it will transpose and then
it will convert. Correct. It will convert this vector in the form of a row vector and then multiply it. Because how you have defined this vector X with the help of one-dimensional array. So it will directly automatically adjust. And then it will directly calculate.
At the rate is will try to ensure that for the matrix multiplication, the order is properly there for both the matrix and then multiply.
Correct. But the only thing that you have to take care is the vector you should not be defining with the help of two-dimensional array. If you will define that itself is a matrix, then you are doing just a matrix multiplication. You're not doing anything else. So for matrix multiplication, let's for example this X that is 6, 7, 8. If let's for example you have defined this, you have told the computer that this is a matrix of 3 cross 1. Then you have to take care of everything. Like whenever if you have to multiply X transpose X, then you have to take X ka transpose and then multiply with A. Are you getting me or not?
Okay. For array, this at the rate will take care. If it is matrix, then we need to ensure
correct.
The inputs are right for the product to happen.
Yeah.
That the rate will not help.
Yeah, at the rate will not help. If it is the dimension is correct, it will multiply. Otherwise, it will throw an error.
It will throw an error. Okay.
Correct. So let's for example, this is 7. It will throw an error because the dimension is not same, right?
Yeah.
Sir, hello, sir. Sorry to interrupt you. How to take the user input?
How to take the
user input? Like if I have to enter some matrix elements, because right now we are doing the exercise with the existing elements, right? We are directly taking them to, so suppose if user wants to enter the elements, then how we should take through this NumPy, or is it the formal Python program we need to use?
Yeah, the normal Python program that you use, but I don't think so that everything will be given to you right here. So whenever you will be dealing with, let's for example, you are dealing with a data set, right? The data set will always be given to you, right? You don't have to put in any data set extra.
Okay.
Yeah. So that's why we don't have to use it, like to give it to give an input, live input, right? Something like that. So everything will be given to you. So you can just define everything as it is that we are defining, the way we are defining.
Okay.
Sir, once more.
Yeah. Go ahead.
Sir, once more, please explain this X transpose Y equal to 32. How we can represent X transpose in NumPy? I could not understand.
So see, just define it. You don't have to write it X transpose. Why will you write? If let's for example, you're just defining with the help of one-dimensional array. If you're defining with the help of one-dimensional array, correct? You can directly use it at the rate, right?
Okay. both in the same way.
So, yeah, you can just write it as @y. That will give you the answer, right? 32. If you just get it as int of this.
Yes, but what I did that I expressed x as an np dot
Matrix.
array, just like you, and then transpose the x, and then multiplied with y. The result was different. So I asked.
The result is different.
Yes.
What same answer you'll be getting because
no, not the at the rate of x dot t star y.
no, star y will do the like element wise multiplication, right? So 1 will get multiplied with 4, 2 will get multiplied with 5, 3 will get multiplied with 6. Correct?
Okay. Oh,
so at the rate, yeah, got it, right? Okay.
Yes, got it. Thank you.
Okay. Is it clear to everyone? And now if you have to use xy transpose, that's the hurdle here. Xy transpose is not the inner dot product, it's the outer dot product. Where did you use this xy transpose? Can somebody tell me where did you use this?
Covariance matrix.
Correct. You have used it in covariance matrix. So here you can't directly use it as x transpose y. Because again it will calculate you the dot product. So here, so there is a function in NumPy, np dot outer. Okay, np dot outer. That will calculate you the outer dot product. That you tell it as xy transpose. Otherwise, it was a very big confusion, right? X, if you would have used x at the rate y, it can't calculate, right? It can calculate if you will define x and y in the form of a matrix. If you would have defined this 3 cross 1 and 1 cross 3, and then you would have calculated x at the rate y transpose, because you have defined in the form of a matrix, you will get a output as a matrix 3 cross 3. But if you are defining this vector as one-dimensional array and y as a one-dimensional array, then you have to use this np dot outer to calculate the outer outer product. Are you getting me? X and y was defined here, so you can directly use that np has a function outer to calculate the outer dot product. Making sense to everyone?
Yes.
Okay. Now, so the matrix of zeros. So again, the same thing, np dot zeros.
So x and y are one-dimensional, right? That's why it's giving the output in the form of matrix.
Yeah, correct. No, x and y is in the form of a one-dimensional array. So you need outer dot product, right? So outer dot product is a totally different thing. The covariance matrix that you were calculating, right? The covariance matrix was in the form of some matrix, right? So here, if x and y would have given in the form of a two-dimensional array, right? Then directly you can calculate as x at the rate y transpose. Then you will get a matrix. But as you have defined it as a one-dimensional array, so you have to use this. You can use this outer as a function. This outer only you can use it. Otherwise, if you use it x at the rate y, it will calculate the dot product. Okay?
Yes, sir.
Right. Okay. Now, let's.
So what about x at the rate y dot t?
No, that will be same, right? See, that is what I told you. If you calculate the transpose of a one-dimensional array, it's nothing, same. One-dimensional array, if you take the transpose, whatever you want to do, that will be same element. The number of element only you are taking care. Like if you are defining anything with the help of one-dimensional array, the shape will always be same because that's some form of a tuple. Where you the shape will be the number of element. You take transpose, you not take transpose, the number of element will be same, right? Are you getting me? But if you would have defined with the help of a matrix, the matrix, if you will take transpose, then will get converted to a row, to column, and all, whatever. Are you getting me? Are you able to understand this? The one who asked the doubt, is it clear to you?
This question is okay. Then the next one, the one below this, where the x is a matrix. Yeah, x is a matrix. We make it as
see what I'm trying to say. X is a vector 1, 2, 3, right? You just have to tell the computer in the form of one-dimensional array or two-dimensional array. If you would have told in the form of a two-dimensional array, right? This is a one matrix or one column matrix 3 cross 1, and y is a row matrix 1 cross 3. And now if you have to calculate xy transpose, you can calculate x at the rate y transpose. there it will work. You will get a matrix, 3 cross 3 matrix nicely. But if you would have defined this X vector in the form of a one-dimensional array, then this X at the rate Y will not work because you need XY transpose. X transpose Y dot product, it will work. But XY transpose, because you need a matrix in the end, right? 3 cross 3. Your one-dimensional array thing will not work. It can work, but if you have to use this outer wala function. Okay, so it internally it will convert this all vector in the form of a matrix, and then in the end it will give a final output as 3 cross 3. If you're not clear, I'll just try to explain it again. See what happens.
No, thank you. Thank you.
Is it clear?
Yeah, it is. Yeah.
Sir, but it is not automatically adjusting here. Why?
Yeah, it's not adjusting because if you would have given X at the rate Y, it will calculate the dot product, right?
Okay.
That's why there's a function outer has been defined, and the outer function is defined to calculate X vector. You can use it with the matrix form also. There's no point like nobody is stopping you to use the matrix wala concept. Okay, you can use that concept also.
So
And then multiply
will a
directly.
function called inner give dot product? Will a function called inner give dot product in this?
And there is a function, right? np dot that will give you the dot product.
Okay.
It will calculate.
This
Let's
dot is there.
dot
Dot is there. Dot is there.
Yeah,
But is
we'll
there a
get
function
32.
called inner also?
That you can check it. I am not aware of that, but you can check it. So there are a lot of functions will be there in NumPy. Okay, so you can check with the documentation whether it's there or not. Because inner product also can be of n number of types, right? You can define an inner product. So one of the inner product is dot product. Okay, so there can be functions, right? But you can check it in the NumPy documentation. Okay. Now let's move it faster because we have one more collab. At least one more collab will be doing. We were having 5 collab, but at least we'll finish 3, right? So how will you define the zeros? That's pretty same, right? You can just directly calculate it np.zeros, right? I guess again the same thing mistake on do zeros. And what do you want? Oh yeah, whoever is asking, can you just
Yeah, sir, I was asking, we can get the recording of this session, right?
Yeah.
Where can we get that?
We'll upload it on the YouTube of the MLT.
Okay, and the link will be shared in the G space, right?
Yeah, I'll share it.
Okay, sir. Thank you so much.
Okay. And whoever has not been added, please ping me on I already shared you the Gmail ID, right? So there you can just message me. I'll just add it. Okay. Okay. Now where were we? We were talking about the zero. Now you have to define a matrix, right? 2 cross 4 matrix. How will you define? So here we can directly give it as 2 cross 4, and we'll be defining it. Same as zeros. Once you just have to write it as ones. Okay, 3 cross 2. Okay, identity matrix. If you need identity matrix, there is a function called IIS. np.I. np dot something, a very nice name, fancy name. np.I, and you need 3 cross 3, right? So we'll be giving you a 3 cross 3 matrix, identity matrix. Okay. For a diagonal matrix, you just have to give the value of the diagonal element. Okay. The np.diag. np.diag. What is that? Yeah, diagonal. And then you can give it all the elements in the form. Let's, for example, the element 3, 4. Okay, there will be in the 1, 2, 3, 4 will be in the diagonal element of your matrices. Is it clear? Is it clear to everyone? Sorry.
Yes, sir.
Okay. Okay. So this indices and slicing. Maybe let's first go to the Matplotlib. So open the third collab. So we'll just go to the third collab. Plotting simple curve that you can open now. So NumPy more or less is done, but slicing is left. Advanced slicing and all is left. So let's deal with first at least the plotting part. So this is pretty simple. We'll just go it very fast. Okay. So now let's make a copy of this. Okay, so I'll just the third collab. Just open it the third collab. No, I'm not skipping. We have to deal with that tomorrow. Also, I told you right. Half of the session will be dealing with the Numpy itself. So tomorrow also we have slicing, indexing, some Boolean indicing also. So advanced indicing that also we have to deal with. So we'll deal with tomorrow itself. Okay, I have to deal with the Matplotlib. At least this is the basic thing that I have to finish it today. Okay. Okay. Now, so the way we have learned about what NumPy, right? So we have okay, one second. So let's close it some of the Google Colab. Now it will work.
Disconnect the previous one.
Okay. So okay, let's move. So the Numpy we have discussed. So there's one more library, Matplotlib. Okay, so Matplotlib will be dealing. So let's import Numpy first as NP, and then we'll import. So there is one more library that is just to that will help us to plot. Okay, so I will plot as PLT. So Matplotlib is also one of the libraries that will help us to plot the mathematical equation functions and all. Okay. So let's, for example, how generally you plot it. Okay. So there is a function in the NumPy line space itself. That so how do you plot any functions? You need x coordinate and y coordinate. Okay. So first you have to generate x coordinate and then y coordinate. Let's, for example, y equals to x square. So there is a function x square, right? So to plot x square, what do you need? Some x coordinate, right? That will lie on that parabola. Okay, some x coordinate and some corresponding y coordinate. If you have x and y coordinate, you can directly join the line and you will get the x coordinate. You will get the plot of that. Correct? So, so there is a one more function that I'll be defining. NP dot line space. So what it does is it will give you. So to get why we are using this to generate some sort of a value. So x coordinate we have to generate, right? For any plot, y equals to log x. So I need some x coordinate, right? And then corresponding to that x coordinate, I will be needing a y coordinate. Correct? So I have to generate some x coordinate, right? So to generate that x coordinate, I have a line space as a function. So how does it work? Let's, for example, I need some values, right? So from 0 to 1. So 0 is the starting point, 1 is the end point. Okay. So 0 is the starting point, 1 is the end point. And how many data set you need? Okay, let's, for example, I need 10 data set or 11 data set or 10 data set, whatever number that you want to get. So it will give you from 0 to 1. Okay, it will give you 10 data points. So let's, okay, you can see that, right? It starts from 0 to 1 and you'll get some 10 data points from 0 to 1. Okay, so this is starting point, this is end point. You can just mark it question mark and then take the help of that help itself. How does it work? So it is starting point, end point, and then this is the number of data point. If you not have written anything, it will give you by default 50 data point, 50. Okay, by default it will give you 50, but you can change also. So I have given 10. So you'll be getting some 10 data point. Is it clear from 0 to 1 itself? Is it clear to everyone?
What is line space? Line space.
I told you, right? This is one of the function in the NumPy itself that will generate different values from 0 to 1. So see, to plot, you have to plot a function y equals to x square. How will you plot? What will be the basic thing? You need some x coordinate, y coordinate, right? Some pair of coordinates, right? X, y coordinate. Correct? To have some coordinate, right? X coordinate, x comma y. What I am doing is I am generating first x coordinate. Corresponding to this x coordinate, I will get a y coordinate. How will I get a y coordinate? I'll just equate it to y equals to x square. So this is some sort of an array, right? So this consists of one-dimensional array with some 10 values. Similarly, corresponding to this 10 values of this array, I'll get a y equals to x square x. So I'll get a 10 values of y, and then I'll just join it. I'll get the plot. Simple, right?
Okay.
So basically we can say it's a line from 0 to 1 which is divided into 10 equal portions.
And the value that you'll be getting is just the point, not the line.
Yeah, points. Yeah.
Correct. Yeah.
Points.
Correct. Okay, now let's, for example, what you have to plot is y equals to x. How will you plot y equals to x? So to plot y equals to x, you need what? Some values of x that should lie on that plot, and corresponding to that value, you need a y coordinate. Correct? So now, how will you generate x? NP dot line space, right?
So we haven't calculated the value of y in previous question, right? It's just the value of x.
Yeah, we are not. The first question was just to generate x, not to plot anything. What is there? Anything is there? In order to plot, we need, it was just defined that in order to plot a curve, we need some set of values of x and corresponding y value. And x is independent of x is independent value, right? So now you have to plot the first curve that you are plotting is y equals to x, a straight line. To plot a straight line, at least the first thing what you need is some coordinate of x, correct? So to generate x coordinate, I just use line space, right? NP dot line space, and the value should be from 0 to 1. Let's, for example, 0 to 1. So what do you think? How many is the minimum number that you require to plot any function? What is the minimum number of value that you need to plot a function?
Two.
Correct? At least for a straight line, you need 2. So even though I just get 2 values, right? And then I'll just define y as what? How to define y is equals to x, right? So whatever the value that is there in the one-dimensional array of x, the same value will be there for y itself. And now I just have to plot it. For the plotting, there is a function PLT. So I have just defined it, right? So matplotlib.pyplot as PLT, as a nickname as PLT. Okay. Now PLT has plot as a function, and then I'll just plot it as x comma y. So what we'll do is it will just plot x comma y. Correct? So what it did, see, let's, for example, I just need what are the point that is at plotted. So let's, for example, first I don't want to plot the whole line. I just want what are the data point, what are the data set. So x is what? 0, 0, because from between 0 to 1, so first in the first line, x equals to np dot line space 0, 1. So it should start from 0. It should end to at 2, and I need how many values? 2 values. So it will just be giving you 0, 1 itself. 0 and 1. Y is what? 0, 0 and 1, 1. Right? This is what the value is. The 2 point that you got, right? So scatter is a function in the PLT, the matplotlib.pyplot, that will just be giving you the data point. So you can see that the data point. Now the plot will do what? It will just merge all those data points. So PLT dot plot. What is that? Plot of x comma y. So it will just merge those data points. So you can see that this 0, 0 and 1, 1. Those got merged. So you got a straight line. So this is what I was saying. You just need some x coordinate, you just need some y coordinate, and you just mix, like merge it, right? All the data points. Just with the help of a line, you just merge it. Is it clear to everyone? How do you generate a curve? Is it clear? Can we move to the next part?
Yes, sir. Yes.
Okay. See, what do you think if I would have given 10 values? What was the change that would have made? Was there any changes in this line? Will there be any changes in the line?
No, sir.
No, only you'll get 10 data points. Right? Now you have a 10 data point. Correct? All those 10 data point is getting merged. So this will get merged. The first will get merged to second. Second will get merged to third and fourth, and like. Okay. Now the next part is what? You have to plot again the straight line 5 minus 3x, where the x should belongs to minus 5 to 5. Okay. Now tell me what will be what should I write? NP dot line space. What should I write here? So it should start from minus
20. Minus 5, 5, 20.
5,
20. Correct. Because you need 20 equally spaced data points. correct? And now, how will you plot y? Y you can directly write it as 5 minus
minus 3x. 3x.
3x. Correct. And now, PLT dot PLT plot x comma y. This is the line that you got. If you want to check which are the data point that you have calculated the plotted and merged, you can just use the scatter also. X comma y. Simple, right? Now the next third curve. So they are very simple. So we are just going a bit faster. Now you have to plot a parabola y equals to x squared. So first generate a data point for the first curve. So for the first curve, what should I write? X equals to np dot line space
minus 1 1 5 minus 1
minus
1 5
comma 5.
5.
Okay, 5. Now, what do you think? Will you be getting a good parabola y equals to x squared? What do you think? If you are just taking 5 data points only, what do you think? Will you get a good parabola?
No.
No, right? Because it will just take 5 data points and then merge it. Draw a straight line, correct? Connecting all those 5 dots. See, now check. So it has just taken 5 data points, equally spaced, and then plotted and draw it has just connected all those 5 points that was there, correct? So it's not a good parabola. Now, if I just increase it from 5 to what value 10, what do you think? Now, this will be a better parabola, correct? But again, this will not be it will not generally reflect the parabola, but it will be much better. Now, if I'll just increase it to 20, again, what will happen? The data point will come much closer, and then the straight line they will just merge it, right? All the dots it will connect, right? If you will just increase much higher, let's for example, you're just increasing to 50. Now, what will happen? The data point will come much closer. If the data point is coming to much closer, and then if you are just connecting those dots, it will start reflecting your parabola itself. This itself is not a correct parabola because you are just taking 50 data points. Okay, maybe if you just go here and because it's not reflecting, just a straight line, just connecting all those dots, but it is resembling at least, right? Now we have taken 50 data points. The data points came much closer, and then it started resembling the parabola itself. Okay, clear? Now you have to tell me the fourth curve. You have to plot y equals to 3, a straight line that should be parallel. Okay, y equals to 3 will be parallel to x-axis or y-axis?
X-axis.
X-axis. So you have to draw a plot y equals to 3 that should be parallel to x-axis, and x equals to 5 parallel to y-axis. Okay, and then color and all you have to give it, and then you have to limit the value of x from 0 to 6 and limit the value of y equals to 0 to 6. Okay, and then you have to label x and y. These all things I'll tell you. But first thing is there can be n number of things, right? So we are just telling you how to calculate. At least add the title and x and y axis, and then add a legend. I think. Okay. The first thing that you have to tell me, how will you plot this? So x data should lie from 0 to 6. So x is equals to what? Np dot line space
of 0,6. Okay.
0,6. Okay, it's fine. Now what next? Even it's a straight line, right? You can just take a 2 values itself, that will suffice. Or maybe you can take any number of values, but 2 values itself will suffice. Now, what do you think? What should be the y? Y is equals to 3. No. How should you define it?
Y is equal to x.
3.
No, y equals to x. How can you define y equals to x? That will be a straight line.
Y equal to 3, right?
How will you get a one-dimensional array having all the values at 3?
Lin space 3,
np dot ones.
whatever number of
np dot 1. Correct.
Lin space.
Yeah, np dot 1. How many values you need here? What should I write here?
2.
2, because we are just taking two values in the x coordinate, right? 2. Now, what should I multiply with?
Into 3.
Correct. I'll multiply with 3. So now I got a y as 3, 3,3. Correct? Now you have to plot it.
Yes.
Just plot it. PLT dot plot x comma y. So you got the correct, right? You got a straight line that is parallel to x-axis. You can add so many things. Color also you can add. So I hope color should be there. I hope you can check it in PLT. Color should be there. Color you can just take any color. Let's, for example, I'm taking blue color. Okay. What else? Color the first one green. Okay, so I just colored it as green. Okay. And then what else? The second one as red. So I'll just. How will you define the second one? How will you plot the second one?
Y equal to np dot linspace.
Correct. Y equals to np dot linspace
0,6,2.
0,6,2. Correct. What about x?
And like x equal to np dot ones.
np dot ones. Correct.
2.
Value should be 2. Multiply with
into 5. Into 5.
Into 5.
Into 5.
Correct.
Sir,
Now,
can you
yeah.
please explain why we are using y equal to np dot ones?
Why we are using C? We have defined x as, I told you, to plot any curve, you need x and y coordinate, correct? So to plot y equals to 3, what do you need? Y equals to 3 is parallel to x-axis, correct? Parallel to x-axis with y equals to 3 as a value. Are you getting me? So you can take any value of x, but y should be what? Y should, if you are taking x as, let's for example, one data point as 1 and the other data point as 2, correct? But the y value should be 3 always. So I have taken x as what? Np dot line space 0,6. So between 0 to 6, just give me two equally spaced data point. Okay. Now
Yes,
I
sir.
got two data points. I need y the value always 3. Because y equals to 3 I have to plot, right? So I need I need a one-dimensional array with all the values should be equals to 3. So what will I do? I'll just get a one-dimensional array with all the values as 1. So np dot ones with 2 in the bracket will give you a tuple of 2 elements, and that will get multiplied with 3. So we'll be having a tuple of 3, 3. Okay. So now I'll be having x coordinate and y coordinate both. X can be any value, y should be 3. Are you getting me? And then I can plot it x comma y.
So instead of ones, you can also use linspace, right?
What instead of one?
Ones, you can also use linspace on the same value. Let's say 3, 3, 2. So on which makes a tuple.
Yeah, that also you can do. Yeah, that also you can do. Okay, so now if I have to plot it, what will I do? Plot x comma y. What is the color that I should be getting? The color
equal to red.
Yeah.
Color equal to red.
Color equal to red. Got it? Now I have to use a legend also, right? So I have to label first of all x and y axis. Okay. So to what is there? To label x and y axis, right? I guess there is something dot x. Yeah, here it is. And we can just put it as some color as black itself. Similarly, this is a x-axis, right? And then similarly, you can have a y-axis itself. PLT dot. Sorry.
We can only use grid.
Yeah. Okay. So this is for the vertical line, and the color you can give the same color. Okay, so that will just give you at least the x-axis and y-axis. Now you have x-axis and y-axis, correct? Now what else you need? X-axis and y-axis done. add a suitable title. So title you can directly plt.title itself. So that's very simple. You can just plt.title.
So, sir, here label is equal to like in the x-axis we write y is equal to.
Yeah, you can just give the label also. LEBEL label equals to whatever you want to write. What is the equation of a line? Y equals to 3, right?
3.
Okay. Here also you
And
can
if-
give the.
we give the color also.
Here you can give x equals to 5. Okay. So and the title also you can give it as anything. Like the straight line. Straight lines. Okay. The title you have given. So now everything should be there. Okay. So the label, it will add label when you will add a lesion, right? Okay. So yeah. So now you have added the lesion. So the whatever the label that you have given, the label has been correctly mentioned. So label lesion, this is what the lesion does. So you have given the label. So it has, so red color is marked it as x equals to 5 and the green color is y equals to 3. Okay.
So
They're all
what does
with the help of the practice you'll be able to get it. Yeah, go ahead.
yes, so what does the lesion does? I do not get it.
So whatever the label that we have added, right? So see, if let's for example, I'll just remove the lesion. So the label will not be correctly mentioned. We have given some label also, right? That the first curve, so the label was wherever the green curve is there, that is y equals to 3. That should write it that the green color curve is y equals to 3. So to mark it, whatever the label that I have given, the lesion will help us to mark the label. Otherwise, the label was not mentioned. So when we have use the lesion, so the what is that? The label is correctly mentioned. Okay. This is
Yes,
what
sir.
the
And how? Okay, and how did we plot that black line?
black
Black
line
X.
is it's just the x and y axis. So
Yes,
this is what
that's
the
why.
PLT.8 itself.
Okay,
Yeah, this is
okay.
one of the function in PLT itself, Matplotlib
Right.
title. Okay, these are all, there are all lot of things, right? So these are some of the basic, very basic things that we are going through. Okay.
Sir,
Sir,
you
how
have
this
defined x and y for 2 times, right? But how they are in the same plot?
What x and y?
You have defined x and y for 2 times. Like first you defined x as np dot line space 0 6 comma 2, and then below that you again defined x and y. But they are in the same plot.
Yeah. So that's
How
why both the
to?
plot, both the plot has been plotted here, right? You can plot it
show has
separately
been
also. You
run?
can just add it
Show.
subplot also. I just let you know how to add a subplot also. Okay, to plot it differently also. But here, as you have plotted both the curve, it will just be plotting you both the curve. You can add a third plot also. So it will just plot it in the same curve, same place.
Because I thought that it will take x as whatever we have mentioned for second time, right? But it is taking both values
Yeah,
for
it will
x.
take both. Both the function we have plotted will take both. We'll just plot it here itself in the same curve. Okay, let's deal with now the third thing is the subplot. How
Sir,
to
one question.
yeah.
How to show the scaling also? Like if I want to represent the scaling, um, is there a way?
Scaling means what?
It is fixed size.
Scaling.
Scale in the x-axis and y-axis.
Okay, there must be something. You can just the help of this PLT plot. There must be something. So I guess you are talking about the grading, right?
Yes. Yeah.
Yeah. There must be something. So I can't recall it, but there for sure there will be something. You can just use that for this PLT plot itself. In the plot itself, there will be a lot of things that you can keep on changing and all, right? So you can just explore that to get an idea about what else you can do. So for sure, there will be read also.
So here, how to label like x-axis? We write x-axis and y-axis in the
You have
below. in the line below, we write x-axis and vertically we write y-axis. So how to write?
Legend for x-axis and y-axis. What do they represent?
That also you can do, right? You can just write here itself the legend for the label as x-axis or y-axis.
Like title in the below, like x-axis and.
See, what I'm trying to say is there can be a lot of things that you can explore it. These are just the essentials, like just the basics thing. Even
So how to explore these things?
So Matplotlib itself, you can just go through the documentation of Matplotlib itself, or you can just use, I told you, right, for any function, if you need, just mark it as question mark and then take the help of, that help will help you. Or you can just use the ChatGPT like to explore Matplotlib or NumPy documentation. Okay.
So in Colab, we write Matplotlib and question mark, then we see the documentation.
No, not that one. The whole document, the library, it will not be giving you. For some function, it can give you, right? For documentation, you can just directly on the Google, you can get the documentation of Matplotlib or NumPy. So there, all the functions will be mentioned there.
Okay.
Yeah, so you can just keep on scrolling. You'll get an idea about the how to, with the help of like, it's just we are talking about the scatter plot, and so there are bar plot, line plot. So a lot of plots are there in the Matplotlib. Okay, even many times you can use the Seaborn also. That also you can go through. So there are some good libraries. Seaborn also is one library that helps you to plot a lot of. That will also help you to plot it. Many functions. So Matplotlib is a very basic, yeah.
Okay, sir. Thank you.
Okay, yeah. So all those things, whatever you are able to think, right? All those things you can do it. You just have to explore it.
Sir.
Okay? Yeah.
So we already had x and y axis. Then why did you do it again, like in the black line? Why? I don't get it.
If you don't want to, I can just remove it also. That's fine. No problem in that. So it will give you something like that. But this is not x-axis and y-axis. Like the one that I wrote it earlier, that was the original x-axis and y-axis, because you can see that 0, 0 is not at the origin, right? So that's why, because in the question it was given, right? X and y-axis should be there. So that's why I just wrote it as. But if you don't want, you can just plot it like as it is. The only thing is we are just going through how to plot a very basic function. That's it. All those things, adding legend, adding grade and all those things, you can just explore it and get an idea. Okay.
Okay, sir. Thank you.
Is it clear? Yeah. So now, if let's, for example, many times what happens, you want to plot it in a single screen, you want to plot 4 different functions. How will you plot that? So there, a function called subplot will help you. Okay. So in this PLT, the matplotlib.pyplot, you have a subplot that will help you to plot n number of different functions. Let's, for example, you need 4 functions, right? So to plot, first of all, let's plot it. So the x should vary from 1 upon e square to e cube. Okay, what should I write in the form of a line space? X should be
np dot line
space
1 by e square.
1 by np
dot 1 by np dot e.
Correct. np dot e.
Start 2.
Correct.
Count.
Now
np dot e
start 3.
Level start 3.
Correct.
3.
Okay. So yeah. Okay. So by default, it will take you 50 values. Correct. Now what is the y? Y should be equals to what? np dot
log. np dot log.
Correct. Now if I just want to plot it, plt dot plot it, it should plot, right? Yes. So it will plot. So you got it. Now what I need is this should be in the single screen. So first I plotted, and the second plot that I will plot, what do you think? What will be the second plot? Y x equals to line space
0, 3.
0 to 3. Y should be equals to, I guess for exponential function, what is that? np dot x. Yeah, exponential function.
Double
EX.
star.
Yeah, correct. So this is the plot, and then you can just do it as plt dot plot x comma
X line.
Line space or line space.
Sir, isn't it np dot line space in X?
Oh, okay.
Spelling error.
Where is that?
np dot e double star x will also work, right?
Sir, you called
Sir,
the
x equal
function.
to
You
sir, x
Instead
equal
called
of
to
np dot line space, you write sir
x
line space
np
X.
dot line.
Oh, sorry.
np dot e double star x will also work, right?
Yeah, that will also work. Now, what? Can you just repeat it? np dot?
np dot e double star x.
Oh, that should also work.
Y equal to np
That
dot
should
e
also.
double star x.
Yeah, that should also work. Okay. Now, so you can see that I don't want in single like plot. I just want side by side. Okay. So to get side by side, there is a function plt dot subplot. Okay. Let's for example, you need 4 plot, right? So if you need 4 plot, you can just represent it in the form of a 2 cross 2 matrix. Like it's not like exactly matrix, but 2 cross 2. And the first
Sir,
plot my this logarithm function. So I can write it as 1 here. Okay. So the whole plot, because I need 4 plot, right? So 4 plot should be in the form of 2 cross 2. And the first plot should be this my logarithm function. The second function should be this exponential function. So the second function I can write it as plt dot subplot this 2 cross 2 comma 2. Now if you see the, what is there? Okay, see this should be plt, right?
plt dot plot plt dot.
Yeah, correct. So plt dot subplot. Yeah. Now you can see that side by side the function is logarithm and the second function is exponentially increasing function. Okay. Clear? Now what else I need? And the third and fourth, I need 4 functions, right? What will be the fourth one? I have a sinusoidal curve. So how will I write it? So x equals to np dot line space
Line space 0
from 0
comma 2 into np dot pi. 0
pi, right?
into np dot pi into 2.
Is it clear? Yeah. Y equals to np dot sine is there? Yeah. And now you can plot it. Plt dot plot x comma y, right? And then this should be the third one. So the first one is the logarithm, second one exponential, third one should be a sinusoidal curve, right? So plt dot subplot. It should be 2 cross 2 because we need 2 cross 2 matrix in the form of 2 cross 2, but the third plot should be the sinusoidal curve. Okay, so now if you'll just can see this, right? The third one is the sinusoidal curve. Now the fourth one is, what is the fourth curve? Is the 1 upon x, right? So again the same thing, x equals to plt dot sorry, what, np dot, right? Np dot and space, what is that, from 0 to 5. So by default will take 50 values. Now I have to define what y equals to 1 upon x, right? On x. PLT.
Sir,
Yeah, go ahead.
by default, line space will take how many values?
50 values.
Okay.
50 values will take, yeah. So subplot, and what else you need? You need in the fourth, right? 2 cross 2 plus 4. Now all the 4 will, yeah. So you can see that in a single plot. Yeah.
One thing, this you did 0 to 5, so 0 will be included and 1 by x will not produce error.
You can just take it as 0.00. Is that fine?
Yeah.
Yeah. So it will not be defined at 0. So it would not have taken 0. Okay. If we are taking 0, did that throw any error? Yeah. So it has this runtime warning, right? It has given some. So it has taken not exactly 0. It would have started from some 0.00001. Okay. Yeah. So here it has given some, right? 1 upon x runtime warning. It has given divided by 0 and counted in. So it has given some error also. So you can take 0, but it's better to just mark it as 0 point some 0.00000. Okay. So I hope it's clear. Now you can just give title and other things also. So is it clear? At least the basic part of the. So this is what I was about to discuss for the Matplotlib. So at least the basic idea about the Matplotlib is clear, right? How to plot a simple function and all, right?
Yes, sir.
So tomorrow we'll go through whatever the indices, the slicing and indexing has been left for the NumPy, and then we'll start with PCA and the regression. Okay. So everyone did along with me, or just?
Yes, sir. Yes. Most of them.
Okay. So the same thing will be asked in the OPP also. So whatever, not a single thing will be not be whatever we have not discussed. Not even a single thing will be asked in the OPP also. It will be more or less the same thing whatever we are discussing here. Okay.
Sir.
Yeah.
Are there any OPP questions for practice?
Yeah, I can give you on the 4th day. Okay.
Okay.
First, you just go through whatever we are discussing, and in the last day, I can just give you an idea about previous term one of the papers. Okay.
Okay.
Sir, the lecture.
So G space addition you will be doing.
Yeah. So yeah, you just ping me there. I'll just because from here I didn't copy the mail IDs whatever. Okay.
Okay. So where should we send email?
I just give you the mail ID. Mine vishal@study.iit.ac.in. So this
Your post. Okay.
Sir, can you please upload the lecture before the upcoming lecture? This lecture in YouTube.
Yeah. I'll just upload it after the session.
Okay, sir.
So will there be any practice questions or like exercises or something like that? Okay.
No,
Or this is
yeah. So whatever the
can practice in this this only.
Whatever the Google Colab that I'm sharing, that is more than sufficient. Like at least for the basic part, there are a lot of sources from where you can just practice it. They're just the basic essentials that we are providing. Okay. If need, I can from where and all you can. So documentation you can just go through for the NumPy. So this is the homework for you all guys. Just go through the documentation of NumPy and Matplotlib. Okay.
So this OPP, will there be multiple slots or just one slot?
It will be one
slot. Able to choose
slot. Only one slot.
Well, will it be in the second half or first half?
So what do you want?
Second half would be.
I have to tell them the time.
Yeah, prefer second half, sir.
Yes, sir. It will be.
But many of
first
them.
Half we go to. I mean, that's whatever the majority is good. Second half is I said because I go to church in the morning.
Oh. Yes, sir. I have an exam from 10 to 12 on the same day.
So that is what. Like I don't know how many of you are comfortable with evening slot, but whatever timing that you will be telling, that I can fix. The date also I was about to ask, but date is fine. I just discussed.
Yes, sir. Please keep it in evening.
So.
Please keep it in evening, sir.
Sorry, when is the date actually?
11th.
11th of May. Yeah.
11th of May. Thank you.
Sir, will you be sharing this sheet also? The solution?
Yeah, I've already shared. I already shared this. But I'll share it in the Google space again. Yeah, G space again. I'll be sharing it after the session. Again, the today whole this Google Colab I'll be sharing. The whole 3 that we have discussed today will be sharing there. Yeah, Sam.
It will be sent to a mail, please, sir.
What?
The sheet sharing will be sent to the mail ID.
No, in the Google space I'll share because mail ID is very difficult for me to share with everyone. In the Google space there's a group, right? I hope everybody is there. So if you're not there, that's why I gave you the mail ID. You can just ping me there. I'll just add it. Okay.
Okay, sir.
Sir, send your mail ID again.
It's there in the pin. I have already pinned my mail ID.
Sir, can we leave?
Yeah. So that's it for today. So thank you all for joining it.
Thank you, sir.
We'll meet again.
Thank you so much.
Thank you, sir.
So
Thank
kindly
you.
consider that exam timing post 3 o'clock on 11th of May.
I'll just check with the team. If I'll just ask you in the group also some poll or something, and we'll go with the majority. Okay.
Thank you, sir. Thank you very much.
Thanks.
Thank you.
Thanks everyone for joining it up.
Thank you so much.
Meet tomorrow.
Thank you, sir.
Okay. Thanks.
Thank you, sir.
Sir,
Yeah, Kausab.
yeah, sir, from where I can get the recording of today's class?
I'll just upload it after the session, and I'll just post it in the G space also.
Okay, sir, okay.
So this solved, whatever you have solved is not available.
I'll just
Or you
upload that
will be
solved
sharing.
also. So I'll just share the Google in the Google Drive. I'll make a new file where the solved one I'll upload it. Okay?
Sir, we have sent a mail, so you'll be adding us to that, huh?
Yeah. I'll just add it now itself after the session. I just got some mail. I'll just upload it. Add it. Whoever is not been added.
Oh,
I don't know
from there
how
we can.
people got missed. I don't know how. They have added everyone. I guess 400 people registered. Almost 350 are there. Like I don't know how they have missed it. Some. I'll just check with the ops team also. Okay.
Probably we are not clear where to find this. I think.
MAD 2. It's not
Sir?
related to MAD 2. If you have just finished MLT, that's it. Okay, no problem. I'll add it, and then I'll check with the team also why there is so many people have not been added. Okay.
Thank you, sir.
Okay. Thanks everyone. I'll just close it off. We'll let.
Excuse me, sir.
Yeah.
Thank you.
Sir, could you please repeat the time for tomorrow's lecture?
Tomorrow 8 to 10, same timing.
Okay, sir.
Okay. Thanks everyone, and have a great
Thank
day,
you, sir.
night.
Good night, sir.
Okay, thanks.